So let's talk about the comparison between the different thermometers now. The first thermometer that we're going to explore is the mercury in glass thermometer, or we call it liquid in glass thermometer. Because the liquid that you use need not be just mercury, it could also be alcohol, which is colored with dye lah. So anyway, so let's talk about generally a liquid in glass thermometer, and for the purpose of discussion, let's talk about mercury. So let's look at how it works. So in this mercury in glass thermometer, you will have a large volume bulb in which to store the mercury that will expand when the temperature increases. And surrounding this large volume bulb is a thin glass wall in order to facilitate heat transfer more easily. However, once the mercury gets heated up, the mercury will expand, and when it expands, we allow the mercury to rise through a very narrow tube. We call it the capillary tube. So why must the tube be very narrow, such that you're using a capillary tube? Is because if we remember the formula for the volume of a cylinder, it will be the area times the length. So therefore, change in volume will be area times change in length. So if the capillary tube has a very small diameter, okay here, so the area is small. So therefore, for a small change in volume, it will produce a significant change in length. So surrounding the capillary tube will be a thick glass wall. That one is to prevent heat from being transferred through this side. We only want heat to transfer through the large volume bulb. So the advantages and disadvantages of this thermometer is actually given in uh, the second last page of this chapter, if you refer to your notes. And some of the advantages would be direct reading, simple to use, portable. However, the downside is the disadvantage is that it is fragile because it's made of glass, it breaks easily. And another one more important disadvantage is that it is not very accurate. If you notice, the thermometers in your lab has only an accuracy of plus minus 0.5 degrees centigrade. So therefore, accuracy wise, it is one of the worst. So it is not used to measure any small changes in temperature. The next type of thermometer that we're going to talk a little bit about is the platinum resistance thermometer. Now, for this type of thermometer, you don't have to know it. You don't have to know in very detail. All right, so you just have to know just a little bit of it in the sense how you use it, and the advantages and disadvantages. Now, for this type of thermometer, it is called a type of resistance thermometer, but specifically the name is called a platinum resistance thermometer, and it makes use of the thermometric property that the resistance of a metal increases with temperature. So for the platinum here, if we increase its temperature, we will expect its resistance to increase. So how do we measure its resistance? First, we take the platinum and wind it around an insulating former. So only this part is of platinum, we wind it on an insulating former. And then the platinum is connected to electrodes up to the Wheatstone bridge. So the platinum itself, after winding on the insulating former, it is placed in a porcelain tube which is filled with oil. So therefore, in order to measure temperature, this part has to be inserted into the object that is going to be measured. So what will happen is there will be heat transfer from the outside to the tube, and then to the oil, and then to the platinum in the insulating former. So for thermometers like this, the heat capacity is actually very large. Therefore, we cannot use it to measure small objects, because if you use it to measure a temperature of let's say a small beaker of water, by the time the thermometer reaches thermal equilibrium with that small beaker of water, the temperature of the water would have dropped quite considerably, such that it's no longer accurate. So for thermometers which have high heat capacity, we actually can still use them, but we have to make sure that you place it in a very large object. For example, you place it in the ocean. So even if it absorbs a lot of heat, it will not cause significant difference to the temperature of the ocean. Another disadvantage of this thermometer, that of course it is bulky because you need a power supply. Okay, you need your galvanometer, you need a rheostat and all those. And but what is the advantage of this thermometer then? This thermometer is considered to be the second most accurate thermometer, because any small changes in temperature will cause will be able to be detected by this thermometer. The resistance thermometer that is more important in your syllabus is this, the thermistor thermometer. So bear in mind, if the question talks about just a resistance thermometer, they're referring to this thermistor. If they want to refer to the platinum resistance thermometer, then they will specifically say platinum resistance thermometer. So let's look at how your thermistor thermometer works. Now remember, in your AS, the thermistor, its resistance will actually decrease with temperature. So therefore, it is a type of thermometric property. So the easiest way to measure its resistance is to take your thermistor and connect it straight to an ohmmeter, which measures resistance. However, this technique is not often used because the thermistor has a very wide range of temperature, somewhere between 1 ohm and 100,000 ohm, whereas your ohmmeter cannot measure the full range. So therefore, the more common way that the thermistor thermometer is used is by connecting the thermistor to a power supply, and then connecting a voltmeter in parallel to measure its voltage, and connecting an ammeter in series to measure its current. So then the formula to find its resistance will be V divided by I. So whenever they refer to the resistance thermometer, please consider this circuit, not this circuit. All right. Right, so what are the advantages of this thermometer? This thermometer has one of the lowest heat capacity. If you have ever seen a thermistor before, you can see that the smallest it can go can be even smaller than a resistor. So it is actually very small, so it's very low heat capacity. So thermometers that have low heat capacity, we can use it to measure smaller objects. Now, on top of it, you will also realize that a smaller heat capacity would mean that it will respond more quickly to rapid changes in temperature. So we would say that thermometers with small heat capacities will be more sensitive to rapid changes in temperature, because it doesn't need to absorb a lot of heat in order to reach thermal equilibrium, so you can respond faster. All right. The disadvantage of this thermometer is that it is not very accurate, because you look at the graph, it's actually a curve. All right, but we are calculating based on the assumption that it is a straight line. Now the next thermometer we are going to talk about is the constant volume gas thermometer. Now it makes use of the ideal gas equation that PV is proportional to T. So therefore your P will be proportional to T if you keep the V constant. Now, for this type of thermometer, you don't have to know in detail as well, because it's not specifically mentioned in your syllabus, but it is advantageous to know, because this thermometer is the one that we use to measure temperature on the absolute thermodynamic scale. So how does this work? So you have gas contained in this glass bulb. So we should be using an ideal gas. So but we will only talk about how to make a real gas behave like an ideal gas later in the chapter. Alright, so for the meantime, let's assume we are using an ideal gas here. And if you place this gas actually in let's say a beaker of hot water or a big container of water, so this is the portion that you need to insert. This is called the temperature probe. So what will happen is, as the gas expands, all right, it will push the mercury from this level lower, and then the mercury, which flows continuously in this hollow glass tube, hollow rubber tube, and hollow glass tube, will move up. So what we need to do then is to adjust this side of the arm because it's flexible rubber tube so that the level of mercury returns back to the original level. And once the mercury reaches the original level, then the gas has maintained its constant volume. And then we can calculate its temperature, calculate the pressure using pressure on this side equals to H rho G plus atmospheric. But you don't have to know in detail, right? You just have to know roughly how it works. So why is this considered the most accurate thermometer? Is because that the pressure varies linearly with temperature. It is not an assumption. It is supposed to be true for an ideal gas, which means to say it gives you the best straight line possible. The last type of thermometer we're going to explore today is your thermocouple thermometer. So how does a thermocouple thermometer work? Let's talk about an example here. Let's say you have a piece of copper and a piece of constant tin. All right. Now we all know that copper is an excellent conductor, and constant tin is a very poor conductor. It has a relatively higher resistance than your copper. So what makes copper a better conductor than constant tin is because copper has many more free electrons. So imagine if I were to connect them at this junction, wouldn't electrons start to flow from copper to constant tin? Yes. So therefore, if you think about it, if I were to take the piece of copper and another piece of constant tin wire, and I were to twist together at two junctions here and here, there will be a flow of electrons from copper to constant tin in this direction. There will also be a flow of electrons from copper to constant tin in the other direction. So the flow of electrons in this direction will cancel out the flow of electrons in the other direction, which means to say there will be no net current, so there will be no voltage between these two junctions. However, if you look at this case here, if one junction we place in ice and one junction we place in boiling water, then there will be a difference in the rate of flow of electrons. Because when the junction here is cold, the resistance of the metals will be low, so the rate of flow of electrons will be higher than this side. Because this side temperature is high, resistance is high, so the flow of electrons is much slower. So the flow of electrons here is faster than this side, so overall there will be a net flow of electrons this way. So when there's a net flow of electrons, there will be a current, and if there's current, there will be voltage between the two junctions. So the bigger the difference between these two junctions, as in the bigger the difference in temperature between these two junctions, the bigger the net flow of electrons. So therefore, the bigger the current, the bigger the induced voltage between them. So this is how your thermocouple thermometer works. So when we are calculating the temperature using this thermometer, it is important to realize that the formula is different from the other types of thermometers, simply because you have two junctions measuring temperature difference between them. So therefore, the temperature, the unknown temperature will be how? So first you place the thermometer, one junction in boiling water, one junction in ice, and we read the EMF. So that will be E100 0. That means what is the EMF when one junction is in 100, one junction is in 0. Then you take out the junction of the boiling water and we place it in the unknown temperature, let's say into your mouth to measure your body temperature, and then we see what is the temperature, what is the EMF when one junction is in ice 0 and one junction is in unknown temperature. So the EMF on top divided by EMF at the bottom times 100, that will be the temperature in degrees centigrade. The advantage of this thermometer is that of course its heat capacity is the smallest possible, because the junction that you use to twist the copper and constant together is actually very small. Now, however, it is also important to realize that in real life, this thermometer is the most widely used thermometer, especially in industries like factories or even in labs. The circuit that we see here is only to help you understand how it works. So how do we modify it? So this is what happens. So what they will have is a copper wire, and then they will have the constant turn wire, and then they will twist together at one end to measure the unknown temperature. But the other side, the other junction, they don't place it in ice. They have actually a computer terminal, okay, where the copper wire, one junction will go in, the other one, the constant turn wire, will enter. All right, so change the color a bit. All right, so this is where the constant turn wire will enter. So the temperature of this side is actually already fixed, which is already known. So because there's a temperature difference between this terminal and the other end where you want to measure temperature, there'll be a voltage or EMF between them. So based on the voltage between these two junctions, we can actually calculate temperature. So this computer terminal here, since it is actually connected to the computer will be able to measure the voltage directly and will be able to perform the calculations in order to get the temperature. So in other words, this type of thermometer is very convenient because you don't have to do any extra calculations. You can just connect the thermometer directly into a computer, and the computer can do the rest for you. So why is it only this thermometer that can be connected directly into a computer? It's because all computers and all electronic devices, they only understand one language, which is actually voltage. So even if you say they understand binary codes, they're actually in the form of high and low voltages. So other types of thermometers, their output is not voltage, so therefore we cannot connect them directly into a computer. Alright, so example, the mercury glass thermometer, how are you going to connect it directly to a computer? You can't. Okay,